Okay, thank you very much, Mr. Chairman, for the introduction. So I'm Tetsuo Sawaragi from Kyoto University, and I'll give my talk with this topic today. Okay, my talk is about our joint collaboration and with RIEC, if right pronunciation, RIEC. Okay, and yes, this cooperative research project lasted for 2 years, including this year. And yeah, principal investigator is me, and yes, the Tohoku University side is Professor Kitamura, and he presented the first in this session. And so this is a collaboration between RIEC and this is a collaborative graduate program in design. All right. Okay. So this is a special program for leading graduate schools. So this is not a research project, but this is an education program. Okay. And this is a final year when we could have some financial subsidy from the next, but which lasts for 6 years. And yes, the Professor Kitamura kindly proposed to collaborate with RIEC and our graduate school, our program for this graduate school. Okay. Yeah, and I would like to say that congratulations to you. And this is a WISE program for AI electronics. Yes, you successfully won this Takuetsu, the acronym program. I don't know how to translate it into English. And last month, yes, Director General Professor Shiroi visited us, and we could have a very useful joint workshop. And in the workshop, yes, Professor Shiroi introduced about this WISE program for AI electronics, and it was a very interesting program. And it just started, and we can collaborate also with respect to such educational program as well. Okay. Okay, so as for this, let me just give you a brief introduction. What is our collaborative graduate program in design? So sorry, it is not a research project, but this is an education program. But let me give you an overview of this program. Okay, so Kyoto University Design School. This is the abbreviated name of our program. KUDZNS. Okay. Okay, so our program is an interdisciplinary program, and this is the joint program collaborated by our mechanical engineering. I am from this area, mechanical engineer, and psychology, management, arts, and architecture. And also the core of this program is informatics. Okay? And arts, unfortunately, you have no department for arts, so we are collaborating with Kyoto City University of Arts. Okay? And this is a core part of our program, but not only restricted to these departments, but also other departments will be related to our project. Okay? And from the outer, yes, other sectors, peoples, and companies and municipal people are also concerned with our program. Okay, and the final purpose of our program is to train talented students capable of designing systems and architectures of human society. So this goal is quite simple, but we would like to stress this, and we want to foster such a people. Symbolized as this plus-shaped people. Yes, you are familiar with pie-shaped people or T-shaped people, but different from those, we stress in this plus-shaped people. The reason why this is this vertical line, this is the specialty, okay? And this horizontal line means some multidisciplinary. Okay? But we would like to stress that, yes, the individual student should come up this, because this is a doctoral student program, and including the master course So this is a 5-year program. So during the 5 years, let them experience a variety of fields, but finally they should be strike out in this. Okay, so this is our goal. So this is the curriculum we designed. So yes, the students are enrolled from these different 5 areas. Okay, but they should take some common curriculum provided from a program, and of course those students should take their own fields. Okay, so in addition their duties, those students are assumed to take the special courses provided from our program. Okay? And during when they finish the 2 years for master course, they proceed to the doctoral course for 3 years, and then the executives cross-shift people. Okay, this is the framework of our design school curriculum. And we newly established this kind of blue parts. This is a domain-independent theory for design, method, and the practice. Okay, and this is a white part. It will be already existing courses. The traditional domain-dependent courses include design theory, method, and practice. Okay, so and the real problem lineup for training and creativity. So the lineup consists of this kind of 3 different, practice from a very short period for a few weeks to the very longer one, lasting for 100 weeks. Okay, so but by gradually stepping up these levels, their interdisciplinarity will be increased, and their view and their perspective will be expected to be broadened. Okay? And also what's important in our education program is what competency could be acquired during this program. And currently, the quality assurance for this kind of education is becoming very, very rigorous and strict. So we established this kind of design innovative index, which was roughly divided into 4 classes. One is for intelligence, and the other is for personality, and the third one engagement and the governance. Okay, so individual can be more further divided into these items, and every year we checked all the students how they feel confident to acquire this kind of competencies, and we traced their improvement. So this is the result. This blue line is the student outcome at the time of the starting the experience 2 years. Okay, at the end of the master course, and this red line means at the end of 5 years. That is, they finish the program. Okay. So these 24 items corresponding to such competencies. And yes, actually, all of the students can increase their levels of the confidence as for these 24 competencies. And also, this program has a collaboration between the academia and industries. And we have established this Design Innovation Consortium, which consists of the 70 companies and industries members. And they also collaborate with our education, and also in the future they are expecting to collaborate as for the research. Okay, so this is a window for promoting the academia industry collaboration as for the research, and not only the research but also as for the education. So now the company people are invited to teach the students, and this is a new trend in higher education. And this is the international collaboration, and this is our KU cousin program. And Harvard in US, and the Delft University of Technology, TU Delft in Europe, and Art University in Finland, and Stanford in US. Yes, these are our partner universities, And it was a very good occasion for the student to learn from this institute. And this is a journey map for the two representative students, but let me skip this. I would like to stress that they experience a variety of things, a variety of fields. And yes, and this journey map is representing such. Okay, let me talk about the collaborative research with RIEC. Yes, the vision of the RIEC and the Cadence collaborative research project is like this. Okay, this is RIEC, Tohoku University, and this is Cadence, Kyoto University, and they should collaborate. And what our target is, yes, now this is very global target, but our goal is human-centric communication design. Okay, and not only the single human, but the community and the global society should be taken into account for our design target. And the ambiguity of goals, requirements, constraints, and the complexity of environment, all of these should be included. And from problem solving to problem discovery, this aspect is now very important. Okay. Okay, this is a framework for RIEC, Cadence Collaborative Research Project. And this is borrowed from the three-plane diagram, which was very popular in US. As for ERC, Engineering Research Center, supported by NSF. But this is a very comprehensive field. Okay? So the bottom layer, plane, represents the fundamental researches. And the second layer is enabling researches. And the third layer is system integration researches, which is connected to the society. Okay? So we academia are very related to this bottom, and we individuals have their own specialties. Okay? But the purpose of our collaboration is to exchange the opinions with each other, and what is common, what can be shared during this. And we should find what is common fields. Okay? And also it can be improved towards this actual system. But now, during these 2 years, we are discussing about these, and now it is a stage that we could find this stage as a collaboration output of the RIEC and our cousins. For instance, this is a RIEC part, brain psychology, advanced sound and visual information system, biological, magnetic information, and etc. And these parts are from our cousins, cognitive psychology and aesthetic metaphoric expression, in Japanese, kyo-kankaku from psychology, and gain theory and just mechanical and the human machine system and data experience and visual things, etc. Okay, so we could find what can be shared, what is a common problem we can challenge. Okay, at this stage, and now we are finding at this second stage. Okay, and this figure is very popular, and Professor Kitamura has already showed the same one. Let me skip. And from these, as for this future, we are focusing on into these three research topics, which is very emergently solved by the society. Okay? The first one is establishment of collaborative production system infrastructure through cooperation of people and machinery. As you know, you know that the population of the workers are quite reduced. So it's quite clear that this reduction of the working population should be replaced by something. Okay, so our idea is to replace them by robots or automation. This is the one option. The second option is how to let the aged people to keep working, even after 60 or 65. So this is only solutions for our future. So the first one is how to introduce the robot machinery and how to collaborate with the people. And the second one is establishment and the training base for skilled engineer. That is, the older aging people should transfer their expertise into the younger generation, but how to promote and how to increase this kind of opportunities for them. And the third one is stretching the healthy life and the working life of the elderly. Okay, so this is our goal. Okay, this is a variation of role assignment between human and machine, and yeah, this is a level of automation. This is a complexity. Okay, so usually, this automated by machine or industrial robot is covering only this area. And as for this, that is too simple to be automated. This is left to the human. And on the other hand, this very complex task has been left to the human. That is, the robot automation cannot replace this. Okay? But in the future, yes, this part will be quite automated because of the introduction of IoT and etc. And as for this part, yes, this in how to make the robot intelligence, advanced robotics can be enlarged this part towards more complex tasks. But maybe the plausible solution will be this kind of step shape, which means that human and the robot should collaborate with each other. And not the robots alone cannot handle this kind of complex tasks. So how the human and the robot should collaborate, this is a very important target of a program. Okay? So let me skip this as our ongoing research. And so this is how to make the robot more advanced. Okay? But this is also, let me skip this. But in the future, such a sophisticated robot is not enough. But it's a robot sophistication should be expanded toward how to collaborate with a human, how to collaborate with the partners. Okay, this is intelligence for sociality. So this is the human and the robot should collaborate with each other, but this requires the development of some novel new technology and for this, the RIEC has plenty of results, also brain science and biomimetic robotic control and interactive content and social interactions and attention and situation awareness. Yeah, we discussed about this topic last month at Kyoto, but we can find very common topics we can share for this kind of topics. Okay. And the second one is how to enable the succession of the skills or expertise from elderly people to the younger generation. And these multiple sensing technologies, wearing sensoring technologies are now enabling this kind of a measurement from the human workers and also from how the instrument and the machines are working. Okay. By integrating these multiple sources of sensors data, we can step into what is the essence of the expertise. Okay? And yes, already conventionally, such expertise are tried to replaced by manuals or on job train OJT, or to record the movie, etc. But they are not enough, so we should develop some other. This is our final goal, and the third one, learning health system for stretching the healthy life and the working life of the elderly. Okay, as for this, so knowledge, KPD, this is the key word. Yes, this is a performance, knowledge to experience, and yes, knowledge to experience, and the experience to the data, and the data to knowledge. Okay, this KED cycle should be iterated, And this is the idea of fluidity. This is a clinical fluidity scale. And we want to stress that how the elderly people should be classified into which, and with some proper intervention, their status of the fluidity can be coming back, that it was improved. Okay, so for this purpose, we should develop some new system for realizing such kind of the resilience for the elderly people. Okay, so this is the final slide, and the data and the design should be connected to the advanced communication. This is our final and common goal with RIEC and our design school. And not only the development of the artifact, and not only the analysis of the human, but we should how they are placed in which context and how the emerging behavior should be, and we believe. This is our goal, and we should develop advanced communication emerging as a crossroad of data science and design. Okay, so thank you very much for your attention.
Thank you very much,